Narrator, VO. Look around at our modern world. Our concrete bridges crack after 50 years. Our asphalt highways melt in the summer. Our multi-million-dollar structures require constant, painful maintenance just to stay standing. Narrator, VO. Now look at this. This is the Pantheon in Rome. Its massive concrete dome was poured nearly 2,000 years ago. It has survived earthquakes, barbarian invasions, and centuries of torrential rain. And it hasn't collapsed. In fact, ancient Roman harbors made of concrete aren't crumbling under seawater, they are actually getting stronger every single day. Narrator, Cam. How did a civilization that lived 2 millennia ago build infrastructure that completely outlasts our own? The answer isn't just incredible history, it's a masterclass in engineering that still secretly runs your modern life. Narrator, VO. When most people think of ancient Rome, they picture gladiators fighting in the Colosseum, toga-wearing senators arguing in the Forum, or marching legions conquering the Mediterranean. Narrator, VO. But Rome's real superpower wasn't its swords. It was its shovels, its survey tools, and its obsession with physical infrastructure. The Romans didn't just conquer territories, they locked them together with concrete, stone, and water. Narrator, Cam. Here's the crazy part, you interact with Roman engineering almost every single day, whether you realize it or not. Every time you turn on a faucet, drive down a major highway, or step into a massive sports stadium, you are relying on blueprint ideas that were perfected in the dusty hills of Latium over 2,000 years ago. Narrator, VO. Today, we're breaking down the incredible secrets behind Roman engineering, why their structures outlast ours, and how their ancient genius is shaping our modern future. Narrator, VO. Let's start with Rome's ultimate secret weapon, Opus Caementitium. Roman concrete. For decades, modern materials scientists were baffled. Standard modern concrete, made with Portland cement, usually lasts anywhere from 50 to 100 years before moisture gets inside, rusting the steel reinforcement bars and causing catastrophic cracking. Yet Roman sea walls, built in 30 BC, are still perfectly intact, constantly pounded by ocean waves. Narrator, Cam. For centuries, scientists assumed the Romans were just lucky. But in 2023, researchers at MIT finally cracked the code. And what they discovered was mind-blowing. Narrator, VO. The Romans used a special recipe that included volcanic ash, specifically from the town of Pozzuoli near Mount Vesuvius, mixed with quicklime. But here was the key trick, they mixed it at extreme temperatures, a process called hot mixing. This technique created tiny, millimeter-sized white chunks throughout the concrete called limeclasts. For centuries, modern engineers laughed at these, thinking it was just bad mixing. They were dead wrong. Narrator, VO. Those tiny limeclasts were a deliberate self-healing feature. When a microscopic crack forms in Roman concrete and rainwater seeps inside, it dissolves the limeclast. The lime reacts with the water, crystallizes into calcium carbonate, and literally heals the crack before it can grow. Narrator, VO. Even crazier? When exposed to seawater, the volcanic ash reacts with salt water to grow a rare mineral called tobermarite. Instead of eroding, the concrete actually grows stronger over time. That's how the Romans built the Pantheon's dome, the largest unreinforced concrete dome on Earth, which has stood unsupported for nearly 1,900 years. Narrator, VO. If concrete was the flesh of the Roman Empire, roads were its nervous system. At its height, Rome laid down over 50,000 miles of paved stone highways and more than 200,000 miles of secondary roads. Narrator, VO. You've probably heard the phrase, all roads lead to Rome. But you might not know that these weren't just dirt tracks cleared through the forest. They were marvels of civil engineering. Narrator, VO. A Roman road was built like a modern skyscraper foundation. First, workers dug down up to 6 feet to reach solid bedrock. Then, they laid down a base layer of heavy stones, followed by crushed gravel, concrete, and finally, tightly fitted volcanic paving stones on top. They even sloped the roads downward from the center to the edges, a technique called cambering, so rainwater would drain straight into roadside ditches. Narrator, Cam. The Romans demanded absolute straightness. If a mountain was in the way, they didn't go around it. They blasted tunnels straight through it. If a valley interrupted them, they built massive stone bridges over it. Narrator, VO. Here is where that legacy hits home today. If you drive down the A46 in Great Britain, the Via Aurelia in Italy, or major routes across France and Spain, you are literally driving on top of Roman foundations. Modern urban planners didn't reinvent these routes, they just paved over the genius of Roman surveyors who mapped the continent thousands of years ago. Narrator, VO. No ancient city could grow past a few 100,000 people because of one simple limit: access to fresh water. But at its peak, the city of Rome had a population of over 1 million people. How did they keep them alive, clean, and fed? Through the sheer wizardry of Roman aqueducts. Narrator, Cam. To move millions of gallons of water every day across hundreds of miles, the Romans couldn't rely on electric pumps. They had to use only one force: gravity. Narrator, VO. Roman engineers calculated slopes with terrifying precision. Some aqueducts dropped by only 1 inch for every 300 feet of distance. If the angle was too steep, the water would rush out and destroy the channel. If it was too flat, the water would pool and stagnate. Using basic tools like the chorobates, a 20-foot wooden level filled with water, they carved channels through mountains and built those iconic multi-tiered archways across vast valleys. Narrator, VO. At the peak of the empire, 11 aqueduct systems poured over 300 million gallons of fresh mountain water into Rome every single day. That's more fresh water per capita than many modern cities provide today. Narrator, VO. This constant flow powered public fountains, massive thermal public baths, industrial mining operations, and the Cloaca Maxima, one of the world's earliest centralized sewer systems. By mastering urban plumbing, Rome invented the blueprint for the functional modern megacity. Narrator, VO. So, if Roman engineering was so mind-blowingly superior, what happened? When the Western Roman Empire collapsed in the 5th century, much of this technical knowledge vanished. The secret recipe for self-healing concrete was completely forgotten for over 1,500 years. For centuries during the Middle Ages, people looked at Roman aqueducts and believed they were built by giants or magic, simply because nobody remembered how to build them. Narrator, Cam. But here is the ultimate twist: we aren't just looking back at Roman engineering to admire history. We are desperate to copy it for our future. Narrator, VO. Today, human civilization faces a massive climate crisis. Modern Portland cement production accounts for a staggering 8% of global carbon dioxide emissions. Furthermore, our modern infrastructure is crumbling, costing nations billions in repairs. Narrator, VO. By studying Roman concrete, material scientists are now creating modern self-healing, low-carbon cements based on ancient volcanic ash formulas. The Romans didn't just build to impress their neighbors, they built for permanence. They engineered structures to last centuries, using natural materials that harm the environment far less than our short-term modern synthetic materials. Narrator, Cam. The ultimate lesson of Rome isn't just about stone and mortar. It's a reality check. True progress isn't about how fast or cheap you can build something today. It's about building things that endure for the generations of tomorrow. Narrator, VO. The next time you turn on a kitchen tap, drive down an endless highway, or walk past a modern stadium, take a second to remember, you are walking in the footsteps of ancient engineers who solved the problems of the modern world 2,000 years ago. Narrator, Cam. Which piece of Roman engineering surprised you the most? Was it the self-healing concrete, or the insane precision of their aqueducts? Let me know in the comments below. I read and reply to as many as I can. If you learned something new today, hit that like button, it really helps the channel out. And don't forget to subscribe and ring that notification bell so you never miss another deep dive into the hidden history shaping our world. Thanks for watching, and we'll see you in the next video.